and we can actually jump through. So what I was saying before is we're not actually going to be using this entire book. We'll use well, that's kind of what I'm going to talk about. So Mr. Ferreira, who's here, if you do grade 11 pre-calculus, you could actually do it next semester if you want to. Some people would actually no, I don't think you can. I think it actually has to be next year, in which case you do grade 11 advanced in the first semester and then grade 12 advanced in the second semester. So if you do decide to do that with Mr. Ferreira, the two of us have sort of split this book up. So we'll be doing part of it in this class and part of it in his class. So that does not mean that we will be getting, like the first, I don't know how many chapters, I think there's 8 chapters. Yeah, it's not like we're doing the first 4 chapters in this class and then the last 4 chapters in his class. I'm going to be jumping around a little bit in this book. And then next year when you do grade 11 advanced, you'll kind of be filling in the gaps. You might have some additional resources for you as well. Okay, so it looks as though Discord is not working. So what I'm going to do, I thought that maybe this would happen. Just give me 2 seconds and, I don't know if I actually have time to do this. Let's see if I do though. Okay, 2 seconds here. I don't think this is going to work. So maybe we just do YouTube then. Maybe that's what we have to do. Okay, 1 more second. Okay, I think what I can do, yeah, okay, here we go. Oh my gosh, okay. Join the server. Just give me 2 seconds here, folks. I'd really like to get the Discord thing working. So I'm just going to, I know that if you're watching on YouTube, you can probably hear me. But I think that if you're on Discord, then you cannot hear me. So I'm just going to quickly, on the fly, sort of try to fix this. Okay, how do I do this real quick? Invite, I want to invite my alternative account. Okay, discord.gg. I know this is really boring while I fix things on the spot, but that's just where we're at.
Yeah, imagine for this office number 1. Yeah. Even if it puts up like 12.3.
Okay. I'm hoping that now you can hear me. Yeah, I just logged into a different account on Discord, and that's why I have 2 Math Bennett's. So if you're on Discord now, I think you should be able to hear me. I can see that my microphone bubble is moving when I'm talking. And I'm hoping on YouTube you can also hear me. Okay, great. This is awesome. I think we're good. Okay, so I'm just going to leave that there. Hopefully my battery doesn't die. Got some money for textbooks. Okay, we're ready to begin. Okay, bit of a bumpy start. That's okay. I am just going to ask for the next couple of weeks that you be patient while we sort of figure out this whole remote learning kind of 50-50 mix sort of thing. But so far, I think it's been going okay. But yeah, there's going to be some bumps along the way. So yeah, what I was saying before is that yeah, this textbook it's a great book. I really like this book. You can tell just by kind of flipping through it, it's almost entirely just questions. So we're not going to get a lot of like learning out of this book. Like this book isn't going to be like your best source for like reading up on a topic. We're mostly using this book for the questions. Now there are some explanations, like there's some examples, there's some definitions and stuff like that in this book, and they're great little explanations. But you're not going to find every little detail in this book. So that's kind of what we're going to be covering in class with these videos and the things that we do together. So yeah, this book is mostly going to serve as a source for practice problems for us. Now, there's a lot of questions in each section, like a lot of questions. You don't have to look very far just to take a look at just one of these pages. And often there's for each section, there's several pages that have maybe 30 or 40 questions each. So what I kind of think about that is, like, this is an opportunity for you to practice, right? Now, if I just gave you, 5 or 6 practice problems, then you could probably feel pretty good about it and then move on. But the nice thing about having like 40 or 50 or 60 practice problems is that you can keep practicing these problems until you feel good about it, okay? So I'm going to make some suggestions for how many questions you should try. Typically what it's going to look like is something along the lines of, here's question 5. Question 5 has like 8 total questions. Do 4 of them, right? So question 5, I'll suggest that you do about 4 or 5 of them. Doesn't really matter to me which one is which. There are solutions in the back for all of the problems. So like if you decide to do the first 4, then you should have all of those solutions if you'd like to check your answers as you go. As well, like later on, if we're kind of revisiting a topic, then there should be another opportunity for you to try some new problems again. That way you can sort of refresh your memory. So we are not going to start at chapter 1. Okay, so we are going to start off with a topic that we covered in grade 9 advanced. I like to think that we did it quite thoroughly, but these sorts of things, it's really easy to forget sort of the process. So what we're going to start off with, I believe it's chapter 4, which is on factoring. So factoring trinomials. So the thing is, we looked at a little thing called trinomials last year. You may remember us factoring trinomials. And we're going to stop calling them trinomials now. We're going to refer to them as quadratics. Okay? So let's think a little bit about what a trinomial is. So I just want to sort of break down this word here, trinomial. So a trinomial is tri, which means 3, right? Like a tricycle is like a bike with 3 wheels. Tri means 3. Nomial, okay, means number. So 3 numbers, okay? And this nomial, this is the same kind of nomial that's in polynomial. Okay? So it's the same nomial. Okay? So we called them trinomials because we weren't really prepared to start talking about something called quadratics. And quadratics is what we're going to be calling it now. So a quadratic is a specific type of trinomial. Okay? And quadratics are going to be like the main topic of study in this class. So we're going to start off with quadratics. We'll kind of get our feet wet, so to speak, learn a few things about quadratics. We might move on to something different, and then we'll come back to quadratics, and then do something else, and then come back to quadratics. So quadratics is going to be one of the main topics in this class. So the first thing to do is just to make the connection of what a quadratic is. So a trinomial is some kind of polynomial that has 3 terms. So a trinomial is a polynomial with 3 terms. So for example, like the most common kind would be something that looks like a quadratic. So this is what a quadratic is. We would also call this a trinomial. So something like that. That's what a trinomial would be. Okay. This would also be a trinomial, though. I'll show you another trinomial. Another type of trinomial could look something like this. Okay? So those would be two examples of trinomials. So both of these are trinomials. So can anyone tell me what if these have anything in common? These two trinomials? Yeah.
They both have the term x in them.
Yes.
And the number 1 in them.
Yeah, they both have x in them. That's probably the most important thing, that they've got a variable in them. And yeah, that's another good observation. They both have a 1. This has no x in it though, right?
No.
Yeah. Does anyone remember what we call those values that don't have an x beside them? Constant. Yeah. Yeah. So we have both of these have a constant. So those are called, that's a constant. Okay. Anything else that's similar between these two trinomials? Pardon me? Yeah, they have some exponents. Yeah, absolutely. Yeah, we've got an exponent there, an exponent there. Yeah. Feel free to chime in on Discord. I think I should be able to hear you if you want. No pressure though.
They have 3 terms.
Yeah, they got 3 terms. Hey, look at that. Wasn't that cool? Yes. They all have 3 terms. Exactly. So 1, 2, 3. 1, 2, 3. Right. And that, by definition, that makes it a trinomial. 3 numbers. 1, 2, 3. Here's one number. Here's another number. So it's got 3 terms. Okay. Okay. So that's how they're similar, right? We could probably find some other similarities, but the fact that they all have the variable x, right? X, and the fact that they all have 3 terms, those are the most important similarities that these two things have. But there's one thing in particular that makes them different, that make them quite a bit different. Can anyone think of what that is? Yeah, go ahead. Pardon me?
The numbers?
Yeah, the numbers, absolutely. So these numbers are different. So we've got a 2 here, a 5 here, a 3 here, a 2 there, a 1 and a -1. Any particular numbers? Yeah. Yeah, we've got some negatives. Yeah, so this one is positive here. This one is negative. In fact, this is the only negative term out of all of them. Go ahead.
Power.
The power. Okay, what makes the power different? Yeah, 1 is cubed. We say this one is squared. Yeah. Yeah, so 1 is cubed, 1 is squared. Absolutely. So that's really, this difference here is what really makes them different. Like really, really different. Okay? And this is something that we're going to spend a lot of time on this year, is looking at what happens when you change that highest exponent. Turns out that is completely going to change the nature of these kinds of expressions or functions, or however you want to call them. Okay, so so let's talk a little bit. Okay, I kind of made a few notes for myself. We're not quite there yet, so let me just leave that for later. I'll do this. Okay, so let's talk about what is a quadratic then. Okay, so what is a quadratic? So we've got trinomials down, so we know what trinomials are. So if both of these are a trinomial, but they have something fundamentally different, what is that thing that makes it fundamentally different? Well, in the world of polynomials, which is what these are different types of polynomials, we tend to be really obsessed with the highest exponent. Okay? So this is a term that I think we may have learned last year, but if not, now we're going to learn it now. So the degree of a polynomial is the largest. I should actually call it greatest, because that's what mathematicians like to call it, the greatest exponent found on x. Okay? So the degree of a polynomial is the greatest exponent that we find on x. So if we were to take a look at this first one, What would we say the degree of this is?
3.
Or the first one?
Oh, the first one.
Yeah, 2. Yeah, the first one, the degree would be 2, because that's the highest exponent we can find. And then I think you're looking at the second one here.
Yeah.
The second one, the degree of this one would be 3. So let's call this, so let's say that a quadratic is a polynomial of degree 2. Okay? That's what that means. I was thinking today, I've always wondered, and maybe you're wondering this now, why is it called quadratic? Because usually quad means 4, right?
Yeah.
But here we're talking about something that's 2. So I was actually just curious. I looked it up just about an hour ago because I thought, oh, maybe that's something that somebody's wondering. Why is it quad, which means something like 4, when really we're talking about something that's all about 2? It turns out, and maybe you know a little bit of French, or even better, you might know Latin. I'd be surprised of that, though, if you knew any Latin. Neither? Yeah?
Sorry, I just have another question.
Yeah, go ahead.
So any trinomial of exponent of 2 or with the degree of 2 is a quadratic no matter what?
Yes. Yeah, as long as that's the highest exponent.
Okay.
Right? Like if I had this, so the question, by the way, if you didn't hear that, was, is any trinomial of degree 2, is that automatically a quadratic? And the answer is yes, as long as we're sure that the degree is 2, so the highest exponent. So if I had something like this, like if I just threw an exponent here, just because I have an exponent of 2 somewhere in the trinomial, does not mean that this is a quadratic, okay? Now, I want to be really clear that a trinomial means there's 3 terms, right? There's 3 terms in a trinomial. Now, not all quadratics are trinomials. For example, x squared minus 1. How many terms does that have? It's got 2 terms. We actually would call that a binomial. This is a binomial. Binomial. Okay? So this is a binomial, not a trinomial, but it's still a quadratic because it is a polynomial of degree 2. The highest exponent is 2. Okay? So we can sometimes we think of them in terms of trinomials. That's how we thought of them last year, because that's just sort of the sort of the introductory way of learning about these things. But we're going to be exposed to the world of quadratics, and the world of quadratics is very rich. There's lots and lots and lots to learn about quadratics. So a quadratic is a polynomial of degree 2. So what we're going to start off with this year is we are going to be thinking about how to factor a quadratic. And last year, we did a lot of factoring of trinomials, right? So now it's going to be the same thing, except we're just going to be calling it a quadratic instead of a trinomial, okay? So that's what we're starting off with. So let's just do a quick recall, okay? So here's a little recall. So you may remember doing something along these lines here. So if I have this binomial, so this is a binomial here. This is I'll put it up top here. So here's a binomial. Here's another binomial. Binomial. Okay. You could also think of these as linear polynomials. Okay, so a linear polynomial, by the way, just so we're clear, is a polynomial of degree 1. Okay, so we've got a degree 1 polynomial that's linear, a degree 2 polynomial that's quadratic. Before long, we'll be learning about degree 3 polynomials. We call those cubics. Degree 7 polynomial, then at that point you just call it a degree 7. I think you could like if we really wanted to, we could start naming them. But it gets kind of annoying naming them at that point. So you start off with a linear polynomial, then quadratic, and then cubic, and then quartic polynomial, and then quintic, and I think after quintic, you just start calling it degree 6, degree 7, degree 8, that kind of thing. I mean, maybe you call it, because I think some people might call it a sextic. It's kind of a silly word, I know. You might giggle a little bit. And then I think heptic polynomial. So it's a lot of the same words that you might be reminded of for like different polygons, right? It's the same kind of counting system. Like I mean, I guess this would be like a triangle. A shape with 4 sides is actually called a quadrilateral. So there's your quad. And then yeah. Anyways, we're getting a little carried away, which is good. I love getting carried away. I love getting distracted. But let's see if we can stay on track. So if I had one binomial multiplied by another binomial, you may remember how to multiply those out. So we would be using the distributive property. So using the distributive property, what that entails is everything in this set of brackets gets multiplied by everything in this set of brackets. Okay? So I take everything in here and multiply it by everything in here. And it's always nice to do this in kind of an organized way. So just sticking with your first x here, and then making sure that x gets multiplied by that x and that b, and then taking the a next and making sure that that a hits that x and that b. So what we end up with is the following. We'll get x times x, which is x squared, right? That's that. And then we get x times b, so that's plus bx. And then after that, let's do full color coding here. How about yellow? So after that, we get a times x. So that would be plus ax. And then finally, one more color. How about purple? Finally, we get a times b. That's a times b. So if we kind of mesh this all together, what we end up with is x squared. I should be writing equal signs here. X squared plus, I'm going to rearrange some of the terms a little bit. This is a plus b x, right? That's how many x's we have, right? These are like terms, right? A and b, ax and bx are like terms. I decided to put the a before the b just because of alphabetical order. It makes it a little bit easier to read. That's the only reason. And then finally, we get plus a times b. Okay. So this is kind of what we're dealing with here. So the theme of what we're trying to do, and it's going to seem a little bit arbitrary first about why we're doing this. We did it a lot last year in my class. I know that we spent a fair amount of time worrying about how to take a trinomial and factoring it into 2 linear factors. And we're going to do that a lot at the beginning of this year, and it might feel arbitrary, and it might feel like, why are we doing this? However, this is one of the most important skills in calculus. So it's really important that we get really good at this skill now. It's going to start making more sense as we learn more about quadratics. In particular, something called the root of a quadratic. We're going to spend a lot of time thinking about roots of quadratics. And what we're doing now is we are extracting those roots. Okay, so it's a big topic of what we're doing right now. So we're going to be trying to develop a skill. And while we develop that skill, or I should say, when we're finished developing that skill, then we'll learn where the skill sort of fits into the world of quadratics. Okay, so it might seem like a little bit like, what are we doing at first? But as we learn more about quadratics, it'll all sort of make sense. So I think that the lesson here is a little bit longer than I intended, but that's okay. We did a lot of sort of chit chat, which is great. So the goal of what we're trying to do is we're going to be given a quadratic that's going to look something like this, and we are going to want to turn it into a product of two linear factors. So factoring a quadratic involves converting a quadratic, obviously, of the form ax squared plus bx plus c. So again, now these are just brand new a, b's, and c's. This has nothing to do with this. This is just something completely separate. I'm just saying this is what a quadratic looks like. So a quadratic, this is a quadratic expression, and it's going to have x squared is going to have an x and is going to have a constant. And in front of each of those, we are going to have a coefficient. So those are the terms that we use to describe the number that we multiply in front of a variable. So we've got, this is what our general quadratic looks like. And then finally, we want to convert it from that into a product of two linear factors, i.e., hello, yeah, that's okay.
Do you know off the top of your head how many kids are in the
Not off the top of my head, but I can find that in about 30 seconds. I think about 15, more or less, but let me give you the exact number. I see. Okay, 20. Yeah, all right. It's 20, yeah. But there's one student who has not showed up yet, and rumor has it that they live in Vancouver now. So,
What?
pardon me?
Is that similar?
No, Xander. Yeah.
Thank you.
Yeah, no problem. Okay, yeah, so our goal is to take this quadratic and convert it into a product of linear factors. So something that looks sort of like this. So maybe I'm just sort of running out of letters here. So let's just carry on with the alphabet. So dx plus e times fx plus g. Okay. And I know that it's kind of, I've kind of given us some alphagetti here, just a whole bunch of letters just spilled out. But that's the gist of what we're doing, is that we're taking something that is initially a quadratic like this, and we want to write it as the product, so two things multiplied by each other. And this is linear because there's only one x to the power of 1, and then another thing that has an x to the power of 1. Okay, and we have no idea what these letters are, and that's the game. That's what we're doing. We're trying to find these numbers. Okay, so I'm going to start off by kind of one of the most sort of straightforward examples, which is x squared plus 7x plus 12. So let's factor this. So let me just sort of explain a little bit about what we're doing. So e.g. factor. Okay, so if we were to factor this, we want to find something, or two things rather, two linear factors. Here's one, here's another one, such that when we multiply them together, we get our original quadratic back. So it's kind of like we're undoing the distributive property, right? Because with the distributive property, I can easily go from this to that. But here we're trying to work backwards. That's kind of one of the main themes of mathematics. Is once you learn how to do something, you immediately learn how to undo it. So let's just scroll back up here. I'm gonna sort of do some copying and pasting. Okay, so I want to copy this and copy that. Okay, there we go. And then I will paste it down here. This is kind of like our little formula here. We're not really going to be thinking of this in terms of a formula, though. we want to think of this more like a process. Okay. So let's think about this process. I should actually put this on the other side. There we go. Okay. Pardon me. There we go. Okay. Now we feel better about that. And then here we go. All right. So this is kind of like our little formula here. And like I said, don't think of it like a formula, because it's not going to be helpful to you if you think about like a formula. But I'm still going to write formula. Okay, so if I have something in the form of x squared, so here's my x squared, so I've got an x squared. And then I've got something that is the sum of two other numbers. That's apparently what 7 is going to be. So 7 is going to be this a plus b. And then I've got a times b as this third number. Well, that's what these a's and b's are. Okay? So we're trying to work backwards. So our goal, yeah. So our goal is to find a and b such that a plus b is equal to 7 in this case, and a times b is 12. Pardon me? Yeah, exactly. Okay, great. So that's what our goal is. That's what we're trying to do. So I want to find two numbers, a and b. Their product is 12 and their sum is 7. Can anyone think of such a number? There's such two numbers? 3 and 4, yeah. So this is going to be x plus 3 and x plus 4. So a would be 3 and b would be 4. Or the other way around, doesn't really matter. 4 and 3 would also work. And that's the game. That's really all there is to it. We're trying to find two numbers whose product is the third number and their sum is the middle number. And that's all there is to it. Yeah.
Is there a way to do so that you can tell you can give like a really big number that you can't like tell what the topic would be?
There's like an algorithm for sure. So let's talk a little bit about the process. Okay. So how many numbers can you think of that add up to 7? Like whole numbers? Is that it? Sure, why not?
0 and 7, negative 1 and 8, negative 2 and 9.
So how many are there? How many pairs are there?
A lot.
A lot, eh? Is that a good place to start then?
No.
No, not a good place to start.
Negatives are included.
Yeah. So let's think a little bit more about this process. So I should say, since there are, I'll say, infinitely many pairs whose sum is 7, let's not start there. Okay, let's start at the other thing. Okay? Because there's only a finite number of pairs whose product is 12, even if you include negatives, right? Even including negatives. Now, that kind of falls apart if we start including numbers that aren't integers. You know, like if we start including like irrational numbers and stuff, like decimals, then there's an infinite number. But we're not quite there yet. Right now, we're only concerned with whole numbers. Pretty soon, though, we're going to be looking at the whole spectrum. So the best thing to do is to start by listing all pairs of factors of the constant, in this case 12. Okay, so 12 can be written as obviously 1 and 12. You could do 2 and 6. You could do 3 and 4, and then that's it. There's no point in doing 4 and 3, and then just leave it there. And then they're negatives too. Yeah. Now, that's a good point. If we add them together, we want them to be positive 7, right? It's got to be positive 7 if we add them together. Would it make sense to make any of these negatives?
No.
No, so let's leave the negatives out of it. Because we don't need any negatives. Because their product has to be positive 12, right? So that means if one of them is negative, then the other one has to be negative.
Yeah,
Right.
that's the same thing.
So then it's the same thing. But then when we add them together, we would get a negative number. In this case, we want positive 7. So both of these are going to be positive. Okay. So now all we have to do is just add them together. So 1 plus 12 is 13. That's not it. 2 plus 6 is 8. That's not it. 3 plus 4 is 7. That's it. So that's our pair. So that's the process that we're going to use. We're going to look at all the factors of that constant number. We're going to add them up. Now things get a little more complicated when we're worried about negatives, but we can't learn about everything all at once. I'm going to give you a little bit of time to practice these. I think I have them written down here. So this is the homework that I'd like you to work on tonight. And if you're watching from home, I'm going to post these pages on Google Classroom. So this is page 163 in our book. I'd like you to do numbers 1 through 4, all of the questions involved in 1 through 4. And then number 5, you can do any 4 questions on number 5. And on number 6, any 5 questions. Okay? So they can be the first 5, right? And when I say like any 5, it's like referring to A, B, C, D, E, F, G kind of thing. I think that number 5 is a total of 8 questions, and number 6 has, I think, a total of 10 questions. So you can do any 5 or any 4 that you want in those questions. Okay, so I'm gonna give you a chance to work on this now. So I'm gonna end the video. If you want to stay on Discord, you can. I am gonna end the video feed though. But I'll leave my microphone on. So if you want to if you've got your pencil and paper in front of you at home, you can keep working. I'll post those questions on Classroom now, so you can download them. If you want, you can print them. You don't have to print them though. But next time you're in class, you will get your own copy of the book. So. Okay. So
We can write in this book.
yes, this book is yours.
Okay,
Yeah.
cool. And do we have to hand these in on Google Classroom?
No, this is for your own practice, your own work. Every once in a while, like I may just come by and check up on you, just making sure that you're actually doing the work. But it's not going to be worth marks or anything. I'm not going to be marking it. There's solutions in the back, so you should be able to get a little bit of feedback yourself. And there's going to be lots of time in this class to work, so don't worry too much about that.